Alright guys, Marini here with another algebra video, our first full week of online instruction. Go ahead and grab Monday's lesson. This is called Monday 323, Factoring with Dots, or the difference of two squares, which I'll explain in a second. We have a 3-question do now here that is factoring. And the only way we know how to factor right now is with greatest common factor. So let's go ahead and take a look at the first one. What would be the GCF, or the greatest common factor, of those two terms? Well, I see 4 and 12 both have a 4 in common. And x to the third and x to the fifth, what do they have in common? Again, if that's still something that you're having a hard time figuring out in your head, x to the third is x times x times x, and x to the fifth. So how many x's do we have in common? There's 1, there's 2, there's 3. So 4x to the third is what the GCF is. So divide both of them by 4x to the third. In parentheses here, we're going to have, all right, 4x to the third divided by 4x to the third, that's 1. Minus 12 divided by 4 is 3. And x to the fifth divided by x to the third is x squared. Remember to subtract your exponents and then put that GCF right in front. And you're done. You can distribute that back and make sure you got the right answer. Number 2, GCF. I'm looking at the numbers 6, 9, and 18. They all have a 3 in common. X squared, I see an x, and I don't see any x's in the other one. That means they don't have any x's in common. And I see a y to the third, a y to the fourth, and a y to the fifth. That means they have a y to the third in common. So we're going to divide all this by 3y to the third, which is going to give us 2x squared plus 3xy plus 6y squared, and then put 3y to the third in front. In this last question here, there's a rectangle, and it has an area of 3a squared plus 3a. And it says find the dimensions. So the dimensions just means what's the length and what's the width. So I want to know how long is that side and how long is that side. To do that, one way to do that is to factor. When you factor, you're breaking a polynomial up into two pieces. So 3a squared plus 3a they have something in common. And you can factor this using the GCF. They both have a 3 in common and also just one a in common. So if I divide both sides by 3a, 3 divided by 3 is 1. A squared divided by a is a plus 1. And put 3a in front. Okay. So that means the length or the width, whatever you want to do. This side would be 3a, and the other side could be a plus 1. Okay. So, coming down here, it says, what is a perfect square? Now, that's something that we used to talk about back in the beginning of the school year. Perfect square is a number that if you multiply it by itself, you get a product like, let's say, 4. 4 is a perfect square because it's 2 times 2. Or 9 is a perfect square because it's 3 times 3. I'm going to go ahead and write out the list of all the perfect squares that we pretty much might have already talked about, such as 16 because it's 4 times 4, 25 because it's 5 times 5, 'But I don't want you to think that perfect squares only have to be numbers. They can also include variables, such as x squared. Why is x squared a perfect square? Because it's x times x. Or something like x to the fourth is a perfect square because it's x squared times x squared. Something that would not be a perfect square would be like something like x to the 5th power. That's not a perfect square. Basically, anything that has an even exponent would be a perfect square. So, question number 1 here, and I'll do these 4, and you guys can finish up the rest. And I even put extra practice down there because this is actually a pretty easy way of factoring. If you take a look at the first question, it says t squared minus 25. Now, you might be thinking to yourself, how the heck am I supposed to factor that? Because there's nothing in common. T squared, 25, they don't have anything in common. Well, okay, that's because you're not supposed to factor this one with greatest common factor. You need to use a different method. And this method is called the difference of two perfect squares. Difference of two perfect squares, or DOTS, is where we get dots from. Is t squared a perfect square? Yes, because it's t times t. Is 25 a perfect square? Yes, because it's 5 times 5. So we have here the difference, or the subtraction of two perfect squares. Notice how there's a minus sign there. This only works if there's a subtraction sign and there's two perfect squares. The way that you factor this is you set up two parentheses, and the first term I see there is t squared. And so you say to yourself, what times what is t squared? And that would be t times t. And also, what times what is 25? So that'd be 5 times 5. And one parentheses has to get a plus, and the other parentheses has to get a minus. And that's it. You're done. So you might say to yourself, well, how can I check that? Well, you can use the box method. If you feel like checking yourself, and you want to use the box method, we'll put the t plus 5 across the top, and we'll put the t minus 5 down the side, and we'll multiply. What's t times t? Oh. T squared. And what's t times 5? 5t. Negative 5 times t is negative 5t, and negative 5 times positive 5 is negative 25. So when I write this out, I get t squared plus 5t minus 5t minus 25. Now that doesn't look like t squared minus 5, but if you look at what the like terms are, 5t minus 5t, that's 0. That cancels out. So you are left with t squared minus 25. Now you also might say to yourself, well, what if I do t minus 5 times t plus 5? It doesn't matter the order. One has to be a plus sign. One has to be a minus sign. That's it. Let's take a look at number 2. Again, I'm factoring it right now. The methods that I've taught you how to factor. All right, from Friday, greatest common factor. Today, difference of two perfect squares, or dots. Well, let's see. Does 4x squared and 9 have something in common? No. So it's not going to be GCF. It's going to be dots. Set up two parentheses. Okay, what times what is 4x squared? That's 2x times 2x. What times what is 9? 3 times 3. One has to get a minus sign, and one has to get a plus sign. And it does not matter the order. Number 3. Again, nothing in common. 4b squared. Difference of two perfect squares. 4 is a perfect square. B squared is a perfect square. So double parentheses. 4. 2 times 2. B squared. B times B. One gets plus, one gets minus. Done. And number 4. Nothing in common between x to the 4th power and 4. So this is going to be another dots problem. X to the 4th is x squared times x squared. 4 is 2 times 2. One gets a minus, one gets a plus. That's really it. That's how you factor the difference of two squares. Now there's a bunch of examples down here. Some of them get a little bit more complicated, but I can help you guys with that during class tomorrow in the Google Hangout. So finish up those and also work on these more practice questions, and I will talk to you guys later.